You may have noticed before that I use the plus operator for like adding for when we assign to variables multiple values, so the plus operator, if you remember that. Well, in this section, we'll be actually mentioning some of actually all the kinds of operators we have in JavaScript. And operators allow operations to occur. So operations are basically any sort of mathematical, any sort of like any sort of work done with data values. So basically, we'll be dealing with numbers in this tutorial. So working with all the operations we have, we have with numbers. We have 5 types of. I divided them into 5 subgroups of operators. We have arithmetic, we have assignment, we have bitwise, comparison, and logical. And we're gonna have a look at all of them. So the first one we have is arithmetic. It has we use the following symbols for those. The following operators. So we have plus, minus, multiplication, division, and yeah, basic and modulo. Where's modulo? Here we go. And there we go. So those are our basic mathematical operators. We also have exponential, which actually doesn't work. I'll talk about that in a bit. So let's just go each one by one. So var A, we're gonna have some variables now. Var B equals 7. Var C equals. So this is addition, just simply adding 2 numbers together. So console C. Pretty simple stuff with pretty straightforward mathematical stuff. So 12. Subtraction, you just do minus, denoted with the dash. Operators are denoted with this pink, like this. This is also an operator, the assignment operator. This is like the main assignment operator, so it means the left side is going to be set to equal to the right side. And minus is a binary operator, which means it takes 2 operands, so it has A and B, left and right operands, left, right. Those are called binary. Binary as in 2. We won't get into. I shouldn't actually say that stuff. In binary, we'll confuse it with bitwise, which works in binary numbers. Anyway, sorry about that. What I'm saying is the left and side and right side are called operands. This is an operand and this is an operand, and that's the operator. All right, so that was subtraction, multiplication, just multiplying them. 35, so 5 times 7, 35. Division. So like in JavaScript, like I said, numbers are 1 type, so it'll return the exact value significant to like 10, I don't know how many digits here, 13 digits, I think. We'll see that in a later chapter. I don't have time to count them right now. Okay, so let's see. And then we have modulo. If you're not familiar with modulo, that is basically you divide the numbers together and you get the remainder. So when you divide it, you get 5. So 5 divided by 7 results in some sort of value. You get 5 afterwards. Now, if that result is kind of weird looking, let me do something simpler that we use modulo for. So I use modulo oftentimes when I want to check an even and odd numbers. So here's 44 even number. And when you divide it by 2, you're checking. So when you modulo 2, you get the remainder of 40. So you get 44 divided by 2 and get that remainder, which is 0, because it's a clean division. That means it's an even number. So when this result from a modulo of the left modulo right equals 0, that means the left side is an even number. So A is an even number, which is 44. That's an even number. So 43, if we do that there, that means we get 1, because if there's a remainder of 1, that means it's an odd number when you modulo 2. So 43 modulo 2 is 1, which means 43 is an odd number. You can often use when checking if an unknown value being inputted is an odd number or even number, which we'll see when we talk more about conditional statements. But anyway, let's move on. So the last arithmetic operator is this star. In this current, there's like sort of versions and types of JavaScript out there on the internet. In certain browsers, certain types of script syntaxes for JavaScript are used. In mine, this operator doesn't work. I tested it before this video. In like sort of W3 schools, it'll talk about it, for example, and say it works in a lot of cases, but in some cases it doesn't. Well, in my case it doesn't, so I can't really demonstrate here. But this will basically, for example, if we wrote up here 2, 5, this should return 32 in some browsers and some interpreters of JavaScript. but in my case, it doesn't work. Anyway, moving on. Let's get to some other arithmetic operators we have. We have a couple more. Actually, they're incremental operators. You have plus plus and minus minus. So what these are, they allow you to increment and decrement operators. These are often used when you're working with iterations such as in loops. So let's take a look at the following. So we're only going to need one variable for this. Let's return that to 44. So we have plus plus. What this does, you see it's supposed to increment the value by a 1. Plus plus. That's what plus plus does. Well, as you can see here, it didn't do 40, it didn't display 45 as it should, but this one will display 45. What this is this is prefix, meaning that it'll increase the value first and then work with it in some way. If you do it after, it'll return the original value and then increase it, or the current value and then increase it afterwards. So let me do this. This is a kind of thing in programming that should be understood. See what happened here? I increased it twice basically, so I should actually remove that. So like I said, okay, give me A the first time, 44, increase it, and then said, give me whatever value A is, increase it immediately. That's what this is called prefix, and this is called postfix. So let me remove this. See, and the next time you get 45. That's because we took it, increased it afterward, after getting it, taking it, and working with it, then its value is 45. The same thing goes for minus. So we said A, give me 44, then subtract it, and then return the value again. So 43, and then prefix. So postfix and prefix. So 43, 43. Yeah. So that's prefix and postfix of these incremental operators. They're also considered arithmetic because you're essentially adding 1 to them. So it's like saying A plus equals 1. And that leads us to our next set of operators, which are assignment operators. They're pretty simple. It's just basically these arithmetic operators and adding an equal sign. So this was the addition assignment, which is basically saying A equals 44, then A plus 1, and then saying, give me back A. This is also, plus 1 is also equivalent to equal sign. So notice here it didn't do anything because that only works on that line itself. But if we wanted to actually, so what we did here, this is some sort of floating global values we'll talk about in scope. So we're saying here A plus 1 at this line is going to be 45. And then you notice here it's not stored to anything. That's because we didn't assign this operation to the value. So we have to assign and add. So we're saying, okay, A's new value is going to be A plus 1. This is equivalent to this, actually. A plus 1. You get 45. Instead of duplicating the writing of A, you just do that. So that's assignment operator. And you do the same thing with all the others. So minus 1, for example. You could actually change the number up. Let's say minus 2. Refresh. Wait, I didn't do that right. I didn't save it. 42. You can do divide by 2. 22. You can multiply by 2. So you multiply and assign. So basically, so you don't have to say plus then equal A equals A plus 2, for example, because if you just do A plus 2 by itself, it won't save. And you can also do modulo as well. And you get 0. So basically, you're saying, okay, give me A, then assign it, assign the value, whatever equal to this operator done with this number. All right, if that's okay. All right, so moving on. So we're following this list now. We have now bitwise operators. So bitwise operators basically allow us to work with binary values. If you're not familiar with binary numbers, you might not get these. So I recommend you, before diving into this, you might want to refresh on binary numbers a little, but I will try my best to show you what everything's doing. So let's say we have a var called bin1. Bin1. We're going to say 7 and 2. Actually, let me actually write out the binary operators, bitwise operators. So we have and, we have or, we have inverse. Where's inverse? The squiggly. I forget what it's called. We have left shift. We have right shift. And I believe that's it. Yes. And we're supposed to have, nope. That is, I believe that is it. No, we also have one more, which I forgot, is I think XOR, which looks like that. We'll explain all of them, don't worry. So here we have 7 and 2. So notice here how I didn't write binary numbers. That's because in JavaScript, when you write the operator, this one, the left and right sides of it will be automatically considered binary. So these numbers would look like this in binaries, just so you don't have to reference anything. So this should be like 0, 1, 1, 1 and 0, 0, 1, 0, which equals 0, 0, 1, 0. When you have bin 1, you'll see that the result is 2, which goes in binary. So this would be 1, 1 is 2, this is 2. Yep, that checks out. Let's do OR now. OR of these two, OR of these two, so look like this. OR would be the following. It would actually be 0, 1, 1, 1. And that number is 7. So we OR operator, which checks basically if you see a 1 combination of 1, 0 or 1, 1, you will get 1 as a result. And by the way, I should have explained, and means if you only have the result 1, 1 comparing to each bit, that means you get a 1. So that's why this one was 1. So that's and now we have, I should say XOR first. XOR. That means we'll have a case where only there want different values. So only when we have 0, 1. So comparing the first one, 0. Comparing the second one, 1. Comparing the third one, 0. Comparing the second one, 1. And you'll see the result. Oops, I didn't change that. So that's XOR, the little shift 6. And that's 5. That checks out. Yep, that's 5. And next we have inverse. So inverse is basically inverts the bits. Let's do that with one number. Actually, here we go. So that's basically not, if you're familiar, not in binary just basically shifts. So we say not 0, 1, 1, 1 equals 1, 0, 0, 0. This is unsigned, by the way. So you actually, no, it is signed. Oh, wow, it is signed. So you get -8 from that. So that's not, you can actually even do this with multiple inverses. So let's say, and not like that, and 5. So you can even do this. That's basically, and you'll get the following. So you can basically mix and match operators. The same thing goes for arithmetic, which we'll get into great detail with more examples as we progress through this course. All right, so that's bitwise operators. Wait, there's a couple more. There's left shift and there's right shift. So these two right here, left shift and right shift. So let's say we have the number 20, and we're gonna say left this one too. So what this says is any ones are shifted off the number are removed. Actually, wait, no. Left shift, what it does, it shifts the bits in the number of whatever place is defined here. So we're saying shift the bits, let's say here, so you have 0, 1, 0, 1, 0, 0, that is 20, shifted to the left by 2 bits, basically translates to 1, 0, 1, 0, 0. And any bits that are shifted off the edge here are deleted for good. So let's do that. And you get 80. So this will check out to be 80. Let me see. Yeah. So when you shift the binary result of 20 by 2 to the left, so you're increasing the number, you'll get 80. And if you do it to the right, so let's do that by 1 instead, and you'll get 40. So let's do it by left by 1. I mean right by 1. You shift the bits to the right now, so going that way, pointing to the wherever this goes, you shift them to the right by 1. And that's going to be basically, so shift to the right by 1 to see more visual equals 0, 0, 1, 0, 0, 1, 0. And that's going to be 10. Yep, so you got 2 and you got, wait, so 0, 1, 0, 1, 2, 0, wait, 1, 2, 4, 8. Actually, this should be shifted to here. There you go, that's 10. That's correct. All right, so moving on, we have comparison operators now. Sorry, this may be a little boring, but I'll try to pick up the pace a little. So comparison operators are basically, they return Boolean values. So return true or false based on what we have. So basically, they're like in comparison mathematics. So you have left greater than less than. You have equal sign. The equal sign in comparisons is always 2 equals because the single equals is the assignment operator. You also have less than, greater than or less than, greater than or equal to or less than or equal to, and yeah. And you have, of course, the last one, 3, which I mentioned in one of the last 2 tutorials. This basically checks for the type, the equal value, and the type, which we'll see right now. So let's say we have var a equals 77, var b equals 66. I say console right. I say a, so equals b. That's going to be false. We're going to say a is less than b. It's false or false. 77 is greater than 66. Let's say a is greater than b. True. And we're going to say now less than or equal to. Greater than equal to, sorry. And then we're going to say less than or equal to, which is false. See, all these operators return false. And now let's do equals equals. So, okay, that's false, obviously. But let's do, so let's say b is actually 77 in a string. If we set it equal with only 2, that's true. Because when you convert this to a number, they're essentially, they represent the same value, the data. So JavaScript's like, oh yeah, that's easy. They're both 77, duh. But what if we don't want that? We want to check if the input is strictly a number 77 and not the string 77. Well, you use the three equal signs of the triple equal sign operator. I forget what it's called. It's like it checks the type, the type, the type, and the value. So this is often used when you're checking input and you want to make sure something's a string or an integer, for example, when you're verifying input. And you'll see this a lot more when we compare operators. All right, moving on. Let's finally do the next. I think that's all of the. Oh, and you also have not. This basically converts the Boolean result of this. So like not, and we have not. I think that's the next one. Oh yeah, that's the next one actually. So we hope this helped, and we hope to see you next time.